Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video we learned question number 3 and question number 4 related with exercise number 5.5 related with chapter number 5 sets and function class 10 mathematics. In today's video we are going to start question number 5 related with exercise number 5.5. It tells that if x set is 1, 2, 3, 4 and set y is 5, 6, 7, 8, then write. There are 6 parts in this question. Part 1 tells that write a function from x to y. So we have x set 1, 2, 3, 4. So let's suppose this is x set 1, 2, 3, 4. And let's suppose this is y set which is 5, 6, 7, 8. 5, 6, 7, 8. And that tells that write a function from x to y. This is x and this is y. So this is a function from x to y. Second part tells that write one function from x to y. So in one function, each and every element of a domain will be mapped with each and every element of the range. So let's suppose 1 is mapped with 6, 2 is mapped with 5, and let's suppose 3 is mapped with 7 and 4 is mapped with 8. So one function are those functions in which each and every element of the domain will be mapped with each and every element of the range. Part 3 tells that write a relation which shows there exists one correspondence between x and y. One correspondence function we already learned in the previous videos that those functions in which each and every element of the domain will be mapped with the unique each and every element of the range. So this is one correspondence. This function is also one correspondence. Part 4 tells that a function which is onto from y to x. So first we will take a y set over here. So y set are 5, 6, 7, 8, 5, 6, 7 and 8. And x set is 1, 2, 3, 4. 1, 2, 3 and 4. That tells that a function which is onto from y to x. So this is a function from y to x, and onto function are those functions in which the domain is mapped with a range. So let's suppose 5 is mapped with 2, 6 is mapped with 3, and 7 is mapped with, let's suppose, 1, and 8 is mapped with 4. So onto function are those functions in which the range of a function is equal to a set B. So here set B means the second set which is y, in which we have 5, 6, 7, 8, 5, 6, 7 and 8. And our range of a function means that the output value. So the output value over here is 5, 6, 7, 8. So here 5, 6, 7, 8 is over here 5, 6, 7, 8. So 5, 6, 7, 8 is equal to 5, 6, 7, 8. So it means that this function is an onto function. So now move to the part 5. It tells that write a bijective function from y to x. So bijective function are those functions which is both one and both onto function. So let's suppose we draw a y set over here which is 5, 6, 7, 8. 5, 6, 7 and 8, and our x set is 1, 2, 3, 4. 1, 2, 3, 4. Let's suppose this is x set, and that tells that write a bijective function from y to x. So bijective function are those functions which is both one and both onto. So in one we map each and every element of the domain with a range. So let's suppose 5 is mapped with 2, 6 is mapped with 1, and 7 is mapped with 4, and 8 is mapped with 3. So no element over here is left not mapped. So here each and every element is mapped. So this is both one and onto is also in which each and every element is mapped with the output. So here each and every element is mapped. That's why this is a bijective function. Now part 6 tells that a function from x to y which is neither one and nor onto. So we draw over here a function from x to y. So first we will draw x. So our x is 1, 2, 3, 4, 1, 2, 3 and 4, and our y set is 5, 6, 7, 8, 5, 6, 7 and 8. And that tells that a function from x to y, which is neither one and nor onto. So onto are those functions in which either a single element or more than one element is not mapped with the first element over here. Let's suppose 1 is mapped with 6, 2 is mapped with 7, and 3 is mapped with 5, and 4 is mapped with 7. So here in the range we are left with a single element 8 which is not mapped with each of the element of the set x. So here it is left alone, it's not mapped with each and every element of set x. That's why this is an into function, not an onto. It means that the function must be an into function. So this is an into function, and also this is neither 1 1, because in 1 1 each and every element must be made with the range output. Move to the question number 6. This is the last question of exercise number 5.5, with which the chapter number 5 will be completed. Let a set is 1 2 3 4 5, then check whether the following sets are functions on a set A. In case these are functions, indicate their ranges which function is an onto function. So solution. First we are going to check whether the following sets are a function on A. In case these are functions, indicate their ranges which function is onto. First we are going to either these are functions or not. So the function will be defined only when there is no repetition in the range. Here the range is 5, 3 and 3 and 2, 1. And the domain we have 1, 2, 3, 4 and 5. So in the domain there is no repetition of each and every element. That's why this is a function. In this part 2, 1, the domain is 1, 2, 3, 4 and 5. So it means here there is no repetition of an element. That's why this is a function. And here the domain is 1, 2, 3, 4, 5. So it means this is also a function. Now that is that in case if these are a function, indicate their ranges. So the range of the first relation are 5, 4, 3, 3. So the range will be 5, here 5 and 3. Here is 2, 3. So it means that there is no repetition in the set. We will take just a single 3. So 3, and after this 2, and after this the range is 1. Y element are actually our range. Here the range is 1, 4, 1, 4, 2, 1, 3, 2, 1 and 3. So we cannot 1 because there is no repetition in a set. That's why we already took a single 1. Here the range are 2, 1, 1. Here 1 is repeated twice, so we will take just a single 1. And here the range are 4, and here the range is 5. So the range is 2, 1, 4, 5. After this they tell that indicate the ranges. So after ranges, which function is an onto function? So taking the first relation 1, 2, 3, 4 and 5 in an x value 1, 2, 3 and 4 and 5. In the range we have 5, 3. Here the range is 5, 3, 2, 1. 5, 3, 2, 1. So here 1 is mapped with 5 and 2 is mapped with 3 and 3 is mapped with 3 and 4 is mapped with 2 and here 5 is mapped with 1. So here not a single element is left which is not mapped over here. So it means the function is an onto function. After this, take this. Here the domain is 1, 2, 3, 4, 5. So 1, 2, 3, 4 and 5. After this the range is 1, 4, 2, 3. 1, 4, 2, 3. Here 1 is mapped with 1, 2 is mapped with 4, 3 is mapped with 2, and after this 4 is mapped with 1 and 5 is mapped with 3. This is also an onto function. After this, taking this, the domain is 1, 2, 3, 4, 5. 1, 2, 3, 4 and 5, and our range is 2, 1, 4, 5. And here our range is 2, 1, 4 and 5. So here 1 is mapped with 2, 2 is mapped with 1, 3 is mapped with 1, 4 is mapped with 4 and 5 is mapped with 5. Here each and every element is mapped. It means that this is also an onto function. So it means that the 3 of the relations satisfy an onto function. So with this question I finish my lecture. Inshallah in the next video I will solve different type of MCQs depend on the relevant exercise which we discussed in the previous video, exercise number 5.1, 2, 3, 4, 5. So on these 5 exercises I will discuss the different type of MCQs related with chapter number 5, sets and functions. So thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification of mathematics. Thank you.